Hello and good morning, everyone. Today, what we're going to do first is we're going to review what we went through last time, because this is something that we're going to see quite a few times, and it's best if we kind of review everything now, just so we're clear on what's happening before we move on. So very quickly, the Big Buy retail chain ships televisions from 3 of its distribution centers to 3 of its retail stores on a monthly basis. So we have a 3 by 3 situation. Each warehouse has a fixed supply per month, and each store has a fixed demand per month. The manufacturer wants to know the number of televisions to ship from each warehouse to each store in order to minimize the total cost of transportation while still meeting the needs of the stores. That's essentially what we're doing now. Now, what we're seeing here, to review that first section, we're shipping from 3 distribution centers to 3 retail stores. That means we've got 9 different routes. That's the key information to take from that. Each warehouse has a fixed supply per month, and each store has a fixed demand. That is relatively unimportant and is really only added to this problem for simplicity's sake. Moving on, we see that what we're trying to do is minimize the total cost of transportation. From those 3 warehouses to those 3 stores, we need to make shipments, but we want to minimize our total cost. That's the key information from this first section here. Moving on, each warehouse has the following supply of televisions available for shipment each month. Cincinnati has 300, Atlanta 200, Pittsburgh 200. What that means is those are the total number of TVs we can ship from there. Any more than that, and it's quite simply impossible. The number of televisions do not exist. You can't ship 400 from Cincinnati because they don't have 400. These are, in linear programming language, very simply, constraints. These are limitations that govern how we can ship. These are the limitations that tell us what is possible and what is impossible. We cannot violate those. So let's go down. That was this section here. Moving on, let's have a look at this section. Each retail store has the following monthly demand for televisions. New York, 150, Dallas, 250, Detroit, 200. So these are, again, constraints. If we don't satisfy our stores, that is not a viable solution. So anything that dictates how we must behave is a constraint. New York needs 150 TVs. If New York has less than 150 TVs, New York isn't happy. That's not a viable solution. So what we've seen in these 2 sections is that we have 300 TVs in Cincinnati, no more, 200 in Atlanta, no more, 200 in Pittsburgh, and no more there. Those are the maximum we can ship from each location. Those are our first 3 constraints. The second one, we see New York, Dallas, and Detroit demand X amount of televisions. Any less than that, any more than that, is unwelcome. These are our 6 constraints. That's what we've seen so far. We're trying to minimize the cost of transportation given these 6 constraints. Moving on down to the next section, we see the cost of transportation of televisions from each warehouse to each store varies. And that's a very natural solution or natural situation because depending on location, depending on transportation costs, distance, modes of transportation, etc., it's very natural for our shipping cost to vary depending on the route we're taking. And the reason we can't always choose the same route is because it's not a one-to-one situation. It's a 3-to-3 situation. So we have to figure out how much each of these 9 routes cost, and then we use linear programming to tell us what our optimal choices are. So we see here X1A, which represents route 1A, is $16. X1B, which represents route 1B, is $18. And it continues, etc. 2A, $14. 2C, $13. 3B, $15. This is what we see in the information presented to us. But when we're entering our information into QM, and we look over here, it makes sense to alter. We could put X1A, no problem. But the problem with that is it doesn't tell us very much. But if we say Cincinnati to New York, we now have an actual route to consider. So X1A, which is also Cincinnati to New York, costs $16. We see that right here. 1A, 1A. And we can even alter these to make it a little more clear. So now what we see as we slide through our situation is all 9 of the routes from Cincinnati to the 3 stores, from Atlanta to the 3 stores, from Pittsburgh to the 3 stores. All 9 routes have now been accounted for. X1A, X1B, X1C, X2A, X2B, X2C, X3A, X3B, X3C. Once all 9 routes are accounted for, now we just have to put together our objective function and write our constraints. That's what we've done here. First, our objective function we can see here. And that lists each of our constraints, each of our 9 different possible routes. $16 for X1A we see here, $18 route B here, $11 route C, which is Cincinnati to Detroit, we can see here. That's what we've done. We've shown our objective function. Next, we have to show our constraints. So our first constraint, and we'll make this a little bigger, is the TVs available in Cincinnati. So what we've shown here is the TVs that ship from Cincinnati to New York, the TVs that ship from Cincinnati to Dallas, and the TVs that ship from Cincinnati to Detroit must be less than or equal to 300. We know there cannot ship more than 300. We don't know if we have to ship all 300. That's how we've indicated this here. We continue in the second one, and we see from Atlanta to New York, from Atlanta to Dallas, from Atlanta to Detroit must be less than or equal to 200 because we only have 200 available. One more time, from Pittsburgh to Detroit, New York, from Pittsburgh to Dallas, from Pittsburgh to Detroit must be less than or equal to 200. And we've seen that here. These are our first three constraints. And what these show is the maximum we can ship from each warehouse. We have three more constraints we saw earlier, and that's how much is demanded at each store. In this situation, we've changed it now to 150, 250, and 200 equal, because we don't want less than 150 or more than 150. We don't want less or more than 250. We don't want less or more than 200. That's what we've seen so far. So how we indicate that is the number shipped from Cincinnati plus the number shipped from Atlanta plus the number shipped from Pittsburgh must equal exactly 150. To repeat, the number shipped from Cincinnati, from Atlanta, from Pittsburgh must be 250. And we saw that right here. Dallas requires 250. Finally, the number shipped from Cincinnati, the number shipped from Atlanta, and the number shipped from Pittsburgh must be equal to 200 because that is what Detroit demands. Once we've put this together, once we have these equations here, all we have to do is enter the relevant data here. So let's look at the first one. X1A plus X1B plus X1C is less than or equal to 300. We represent that with X1A1, X1B1, X1C1 must be less than or equal to 300. Repeating, X2A, 2B, 2C must be less than or equal to 200. X2A, X2B, X2C must be less than or equal to 200. Finally, as far as what is available to ship, 3A, 3B, 3C must be less than or equal to 200. And we see that right here. 3A, 3B, 3C must be less than or equal to 200. All we've done so far is enter, once we've found our objective function, once we properly put together our constraints, this became a relatively simple question. And that's what we saw here. So the key to remember is, if you're solving with QM, once you've put everything into this linear programming format, which we've shown time and time again we need to do, all we have to do is plug the numbers in over here. So let's get rid of this Microsoft Word, and let's make this full screen. Once we have all the information relevant, we hit solve, and what we see, I'll make this a little bigger, what we see is our ideal shipping solutions. We want to ship 200 TVs from Cincinnati to Detroit. That will give Detroit 200 televisions. We want to ship 200 TVs from Atlanta to Dallas, giving Dallas 200 TVs. We want to ship 150 from Pittsburgh to New York, giving New York 150 TVs. But Dallas still requires 50 more TVs, so we ship 50 from Pittsburgh to Dallas, and that gives them a total of 250. So Detroit has 200, Dallas has 250, New York has 150. All of our shipping constraints have been met. Everybody has exactly how many TVs they want. That will cost us $7,300, which we know is the absolute minimum to ship that many televisions. This was just a brief review of what we covered in last class. We'll wrap things up of part 1 right now. When I come back, I'll do the same thing, but I'm going to do it in Microsoft Excel because it does help to have a knowledge of both programs. Thank you for listening to section 1. I'll see all of you very shortly in section 2. Hello everyone, welcome back. In this section, we're going to complete our transportation example that we did last class and we reviewed in section 1. Now what we're going to do in this situation is we're going to do it in Microsoft Excel. So very quickly, let's look at the base question. You can see it here on the left-hand side. We won't review the information because we've covered it a couple times now. However, it is here for you to look at just in case you're having trouble following along with what I'm doing in Excel. So let's begin. First thing we have to do, we have to look at Excel. And we're going to call this our transportation example. Let's keep this simple. Now, after we enter transportation example, typically here we've entered products or revenue, something we're trying to maximize. In this situation, we're trying to minimize. So what are we trying to minimize? From the question, we see we're trying to minimize shipping costs. Now, to do that, we know from our 3 source, 3 destination problem that we're given, we know that we're going to have 9 different shipping routes. So our shipping costs will be based on those 9 routes. That's what we have to enter here. So X11A is Cincinnati to New York. That's what we've seen here. And X1A is correct. That is how we should label it. But for clarity's sake, again, we're going to focus on the Cincinnati, New York aspect. So let's highlight this. Let's make this bold. Our second route is X1B, and that is Cincinnati to Dallas. We go to our third route, X1C. And again, this is Cincinnati to Detroit. So our first 3 shipping routes are very simply the 3 shipping routes that allow us to go from Cincinnati to New York, Cincinnati to Dallas, Cincinnati to Detroit, from origin point 1 to destination point 1, destination point 2, destination point 3. We'll continue. We have X2A. We come down here and we see X2A is Atlanta to New York. X to B, Atlanta to Dallas. And all of this key information is again coming from this grid down here. That is the key information is coming from there. So we had our sixth variable, X to C, and that is Atlanta to Detroit. Okay, we'll make it Detroit. It's long enough. Okay, so these are our first six. We continue one more time because we have three more variables. That variable is New York, X 3, okay, and that's Pittsburgh to New York. X 3, B, Pittsburgh, Pittsburgh to Dallas. And finally, X 3, C, Pittsburgh to Detroit. So what we've done here is we've completed all 9 of our variables. Now, like before, what we typically do now is we're going to add in our shipping costs for each of these. And those are found once again down here in our chart. So $16, $18, $11, $14, $12, $13, $13, $15, $17. So we have now, and I guess we'll bold these again because this is critical information. Make it bold, and let's set it. Okay, this is the key information we've seen so far. Now, what we have to do is essentially we're copying our chart that was given to us in QM. So we're going to come down here and we're going to mention our constraints, or in this situation, requirements. So our first requirement, and we saw this over here, is that Cincinnati has only 300 televisions. So it's TVs available in Cincinnati. Our second constraint, TVs available in Atlanta. And our third constraint, TVs available in Pittsburgh. So this is our first 3 constraints, and they tell us essentially that we have only these many TVs to ship in any given location. We have no more than that possible. We do, however, have 3 more constraints. The first one is TVs acquired in New York. TVs acquired in Dallas. And finally, TVs required in Detroit. So we have these 6 constraints. These govern what we can do, what we must do. So let's move over here to the end. And as before, now usually we've always called it usage, but in this situation we can say shipping costs. Let's say costs. So our first one we know is TVs available. No more than that is available. So it's less than or equal to. We know here, no more than this is available. So one more time, less than or equal to. And if you can't follow right yet, that's okay. I will maximize my screen later. But for now, we need to be able to see the question while we are formatting. So TV is available in Pittsburgh, less than or equal to. And we know here we have 300 available, 200 available, 200 available. We can see that right here in our first graph. Now here we know that this is the amount required. No more or no less. So we make these equal signs. And we know over here, we see that this is New York, Dallas, Detroit. New York, Dallas, Detroit. So 150, 250, 200. Okay, so we've entered all of the relevant data so far. Now what we have to do is, well, I guess before we enter our actual constraints, let's look up here. We see that TVs available in Cincinnati are 300 total. So that means everything that ships from Cincinnati, from Cincinnati, from Cincinnati, from Cincinnati, must be less than or equal to 300. So this number plus this number plus this number must be less than or equal to 300. The next one is TVs available in Atlanta. And we come over here and we see everything from Atlanta, from Atlanta, from Atlanta, from Atlanta must be 1, 1, and 1. And it's less than or equal to 200. See that right here. The last one is from Pittsburgh. So we come over again, make it 1, 1, and 1. Must be less than or equal to 200. Okay, in the next section, we're looking at the number required. So this is the TVs required in New York. To look at that, very simply, we look here. This is to New York, from Cincinnati to New York. So this, from Cincinnati, or from Atlanta, to New York. So here, and from Pittsburgh to New York. These three, the number shipped to New York, the number shipped to New York, and the number shipped to New York must equal 150. That's what we've shown here. Again, TVs shipped to Dallas, Cincinnati to Dallas, TVs shipped to Dallas, Atlanta to Dallas, and TVs shipped to Dallas, Pittsburgh to Dallas, must be equal to 250. One more time, our final time. TVs shipped to Detroit. So TVs shipped to Detroit, TVs shipped to Detroit from Atlanta, and TVs shipped to Detroit from Pittsburgh must equal 200. Now we can do this intuitively, but I'm trying to explain, so hopefully it's a little easier to follow right now. So we've completed that section. Now, what the computer is going to do is the computer is going to run permutations. The computer is going to run possibilities. It's going to look at every possible shipping route until it finds a condition that satisfies our 6 constraints as cheaply as possible. So that's what we're going to do down here, shipping costs. And these are our 9 variables again. So Cincy to New York, Cincy to Dallas, Cincy to Detroit, Atlanta to New York, Atlanta to Detroit, Atlanta to Dallas, and Atlanta to Detroit. To finish up, Pittsburgh to New York, Pittsburgh to Dallas, Pittsburgh to Detroit. So these are our 9 different shipping costs, shipping possibilities. That is what the computer is going to compute for us. We theoretically could do it manually, but it would not be easy. It would be a very difficult, time-consuming process. So what we want to focus on here is allowing the computer to do it for us. So our final situation, what we are trying to determine is our costs. Now, the problem has been set up correctly. Everything has been done correctly until now. So what we can do is we can close our Microsoft Word window and full screen Excel so it's a little easier to see. We'll reduce in size some of these columns just so we can see everything available. So hopefully we can follow along a little better. Okay, we've done that. Now the key is, same as before, we have to enter the formula in Excel that will allow us to compute the correct answer. So let's do our total cost first. This is going to be a little time consuming, but it is very methodical. It should be relatively easy to compute. So we hit enter. Is the cost of Cincinnati to New York times the number of times that we take that route, plus the cost of Cincinnati to Dallas times the number of times we take that route, plus the total cost of Cincy to Detroit times the number of times we take that route, plus the cost from Atlanta to New York times the number of times we take that route, plus the cost from Atlanta to Dallas times the number of times we take that route, plus the cost from Atlanta to Detroit times the number of times we take that route, plus the cost of Pittsburgh to New York times the number of times we take that route, plus the number of times from Pittsburgh to Dallas times the number of times we take that route, plus the cost from Pittsburgh to Detroit times the number of times we take that route. So all we've done here is we've figured out our total cost will be the number of times we take each route plus the cost per route. It's quite simple if you think about it that way. To figure out cost, we look at how many times we took each route and we multiply it by the cost of each route. That's what we've done here. So right now the answer will be 0 because we haven't taken any routes yet. For our cost analysis up here, it's actually going to be easier because I'm not going to do the full total. I'm not going to do all 9. I'm only going to do the 3 relevant ones. Here, these 3, these 3, these 3, these 3, these 3, these 3. So what I'm going to focus on is these. This is what I'm going to multiply because the others are all 0. Because it's 0, we don't have to enter it into our equations. So we're going to keep this a little bit simpler. So let's look over here. First one, to enter our cost, it's the TVs available in Cincinnati times this route plus okay, what we've done here is we've shown that the number of times that we run from Cincinnati so we hit enter and we have 0. We see here this will total this number because it will be the number of times we run each of these. And that must be less than or equal to 300. So we do it again. We hit enter. Again, it will be 0. We continue on. Oh, I made a terrible mistake. That was my mistake. Sorry. What I did was I clicked on the wrong column. So this times this, because this is where the computer is going to compute. Okay, we continue again. Here we do Cincinnati, New York. Atlanta, New York. Pittsburgh, New York. Here we have Cincinnati, Dallas. Atlanta, Dallas. Pittsburgh, Dallas. Cincinnati, Detroit. Atlanta, Detroit. Pittsburgh, Detroit. Okay. So we've completed all our formula. Our 2 groups of formulae. The first one is going to tell us our total shipping cost. The second one is going to calculate in the first 3 how often the routes run, how much TVs are shipped from each location, and the next 3 are going to tell us how many TVs arrive at each location. So we've got 3 different groups, but all of it will tell us how many are shipped from each, how many arrive at each, and then how many or what our total cost will be based on how many times each route is run to ship all those TVs and deliver the required amount. That is what we're doing now. So to do that, as always, we click on Data, we go over to the solver. First thing we do is we're trying to determine our cost. So we click where the formula has been entered. We're also trying to minimize. Changing variable cells. In this situation, we know we're looking at 9 different variations. So instead of clicking on each one, we'll go over here and we'll drag down these 9 columns. Done. Then we set it to Simplex LP, and we're going to add our constraints. So our first constraint, now, like we did last time, because when we have 3 in a row that are exactly the same, all we have to do is this, cell reference. These 3 must be less than or equal to these 3. Oh, sorry. These 3 must be less than or equal to these 3. That's our first constraint. We know that we don't have to enter them manually because they're in a row, and we can see here they're all the same. So we hit add another, and these 3 must be equal to these 3. Hit OK, and we've completed our constraints. So everything has been entered properly. All we do is we hit solve. Solver found a solution. All constraints and optimality conditions are satisfied. This means a solution has been found. Every constraint was taken into account, and the condition that we're trying to minimize cost, that was satisfied. So we hit OK here, and we see that we're going to ship 200 from Cincinnati to Detroit, 200 from Atlanta to Dallas, 150 from Pittsburgh to New York, and 50 more from Pittsburgh to Dallas, which will give us a total cost of $7,300. These are exactly the same results we found when we use QM. Hopefully this is clear. I'm cautiously optimistic that if you've been paying attention, you're following along quite well. Now, one thing to remember is when I assign homework problems, they will not always be exactly the same. There's generally a little bit more challenging because I want you to work towards developing your knowledge. So when I assign this, I'm also going to assign our homework question. The homework question is similar. There are a few additional constraints. So if you have additional constraints, the only thing that generally changes is up here. This question has 6 constraints. You may possibly have to add additional constraints. In the question I gave you, you will have to add additional constraints, and the key for you is figuring out how to write those natural language constraints into the required constraint format. As always, if you have any questions, please let me know. I will be solving the homework problem that I assigned today in tomorrow's class. So if you have problems with it today, please do not hesitate to call me. Have a wonderful day, everyone. Thank you for listening. We'll wrap things up a little bit early because you do have the homework question to consider. Thank you again, and I'll see you tomorrow. Bye-bye.